Hello everyone. So today we are going to present our video, our report, Experiment 1, which is Marcet boiler. Next. So this is the name of students, which is Lim Zi Hui, Muhammad Yusup bin Omar, Saefullah bin Amin, and Hafiz Izzuddin bin Jimat. So this is a table of contents that contained in our presentation for today, which is introduction, objective, theory, working principles, equipment, setup, methodology, results and discussion, safety procedures, conclusion, and references.
Okay, about the Marcet boiler experiments. In this experiment, we need to know what we are going to study about. So, thermodynamic is the study of heat and its relations to various form of work and energy between a system and its environment. Then the Marcet boiler is used to explore the connection between pressure and temperature in saturated system.
So this is the objective for this experiment, which is to observe the relationship between the pressure and temperature for saturated state. So the scope for this experiment, which is that we will push the overflow valve with temperature range from 97 to 100 degrees Celsius. Then record the increase temperature for each pressure of 0.5 bar until reach 5 bar. And lastly is record the decrease temperature for each pressure of 0.5 bar until reach 0 bar.
So moving to a theory and working principle, thermodynamic properties of a pure substance could be determined by two of the following characteristics: temperature, pressure, enthalpy, entropy, volume, and etc. So data characteristic could be obtained either from experiment or equations or using certain. Among two thermodynamics properties that easily measure are temperature and pressure. Relations between these properties could be expressed in the form of graph or equations. Clapeyron equations 1 has published the following. So the below part is the equations, and then where Vf is equals to volume of water, Vg is equals to volume of steam, Hf is equals to enthalpy of water, and Hg is equals to enthalpy of steam, and Hfg is the heat domain of vaporization. Domain for the heat value of water can be obtained from the equations. Next.
Okay, this is the experimental setup. So in this experimental setup, we have drain valve, as you can see in the picture above. Second, heater. Third, overflow valve. Filler plug, safety valve, temperature sensor, manometer, boiler with insulating jacket, temperature gauge, heater switch, and also master switch. So about the methodology, first fill water into the boiler by opening the filler plug. Make sure the overflow valve is open and let the water flow out from there. When the boiler is full, close the filler plug back. Second, heat the water in the boiler with the overflow valve open. Third, when the temperature reach about 90 97 degrees Celsius to 100 degrees Celsius, close the overflow valve. Then note the increase in temperature for each pressure of 0.5 bar until the pressure reaches 5 bars. After that, switch off the heating and record the decreases in temperature for each pressure of 0.5 bar. Finally, we need to record the result obtained in the table.
Okay. Okay. So now for the result, we get in this experiment. So for okay, like you can see in the table for gas pressure 0.5 bar, we get temperature mean is 109.8. For 1 bar is 118.1, 1.5, 1.5 bar 125.3 degrees Celsius, and 2 bar 131.2 bar. 2.5 bar is 136.4 bar. 3.0 bar is we can get 141.0 bar. 3.5 bar we can get 145.2 degrees Celsius. 4.0 bar we can get 148.9 degrees Celsius. 4.5 bar we get 142.6 degrees Celsius, and lastly for the gas pressure 5 bar we can get 154.5 bar.
Nanti buang di back saya lah itu.
Okay, this formula we use in this experiment. So for the absolute pressure, we can get the absolute pressure with pressure of atmosphere plus with pressure gas, and for the atmospheric pressure we is 1.01325, and for the mean temperature we can get T temperature plus with T degrees and divide by 2. So for the dt over dp we can get with temperature mean before and temperature mean after and temperature mean before over by pressure absolute after minus with pressure absolute after. And for the calculate slope we can get temperature mean times with volume of gas over heat of gas. Okay, this table we get the dp dt and calculated the slope. So you can look at the table like for the pressure 1.5 bar you can get the volume of steam is 3.24 and the heat of evaporation is 2305.4, and the rest are. So for the two, okay, and we can get the for the next slide we can get measure slope and calculate slope, and with this with these two value we can get the experimental error of this experiment. Okay, this is a graph of pressure against temperature for heating process. This is a graph 1. Next. Next. Okay. Okay. So for the discussion, okay, the experiment is conducted to study the relationship between the pressure and temperature for saturated steam. As the experiment started, the pressure and the temperature is increased. This is due to the relationship between temperature and pressure as temperature is directly proportional to the pressure, and it can be directly seen from the relation of pressure versus temperature. Graph show the relationship between temperature and absolute pressure for heating process based on the graph 1. We can see the absolute pressure is increased as the temperature. We can see that absolute pressure increase as the temperature increase. When water in the boiler is heats up, the molecules started to gain heat and move faster. As the liquid gain heat energy, it will turn into gas and the steam is not allowed to exit. Thus, the pressure is increased. When temperature increase, pressure will also increase. Meanwhile, graph 2 show the relationship between temperature and absolute pressure for cooling process. From the graph, it is shown that absolute pressure is increased when the temperature increase. Based on the graph plot, both graph 1 and graph 2 were quite similar from the determined slope of the graph as the rate of changing temperature and pressure is about the same for both cooling and heating process. It's observed the cooling process need more time as water cooling is lower than heating up. This is because the water is cooled down and the room temperature with no presence of catalyst to fasten the process of cooling.
So for the safety procedure, as usual, while conducting the experiment, we need to wear our PPE, which is our lab coat. The function is to provide protection of skin and personal clothing from incidental contact and small splashes. Also to prevent the spread. Also to provide a removable barrier. So for the safety shoes, it's designed to protect against foot injury, which is to protect our foot from the common causes including crushing, impact and puncture. Next. So the conclusion, the purpose of this experiment is to observe the relationship between the pressure and temperature for saturated steam. So as the graph shows, the pressure is directly proportional to the temperature. As the pressure increases, the temperature also increases. The vapor pressure curve obtained a slightly vary from typical values due to some errors occurred during the experiment. Hence, precaution should be taken to get accurate results such as removing air from the valve before boiling the water in the Marcet boiler. Next. So this is all the references that we use in our experiment. So that's all. Thank you.